Hey everyone, in this video we're going to talk about section 6.1b, which is going to have us look at an AP free response question dealing with accumulation of change. So hopefully the content itself in this video is actually almost all review, but the goal or the new thing that I want you to take away from it is how can I utilize my graphing calculator strategically. We can do that either by minimizing the amount of careless errors that we can make, especially when we're under a time pressure, or how can we maximize the amount of time and have our calculator do some of that extra work for us. So this comes from the 2005 AB exam, so I'm going to have you go ahead and pause the video. I want you to read through the question stem and then the questions that we're going to answer, and then when you're ready, unpause and we'll talk through some highlights. All right, welcome back. Okay, so a couple things stick out to me. So we're dealing with two functions. R of t is going to be a removal function, so that's taking away sand from our beach, while our accumulation function is S of t, how much sand is being added into the beach. They both have units of cubic yards per hour, and we're measuring our time from t equals 0 to t equals 6. And we also have an initial condition of 2,500 yards of sand at t equals 0. And look, reading through that, I feel like that should be 2,500 cubic yards of sand. Okay, so first thing that we're going to look at is how much sand will the tide remove from the beach during the 6-hour period, and we're going to indicate units of measure. So, I see here that we are trying to remove sand from the beach, and so that tells me that I'm going to use my R of t function. And so since we're trying to accumulate how much sand is being removed, I'm going to go ahead and set up an integral. So we're going to use our graphing calculator here in a second, but let's at least set it up on paper of how we're going to do that, and then we'll go to our calculator to figure out how we're going to type it in. So we're doing this over a 6-hour period, so this is going to be the integral from 0 to 6, and our function is R of t dt. Now, one thing I want to point out to you is you do not have to rewrite R of t as 2 plus 5 sine of all of that stuff. That has already been defined here as R of t, and so I'm just going to utilize that. That's going to save me a little bit of time so I don't have to rewrite my function. So now let's go ahead and let's jump to our graphing calculator. All right, okay, so I'm going to show you how to do this for both the TI Inspire or the TI 84 Plus because it should work with either calculator. Okay, so first of all, I've already gone ahead and I saved my functions in as either F1 and F2 or Y1 and Y2. And so you'll notice here that one thing that you might want to do on your paper, just as a reminder to yourself, is like where you see R of t and S of t written on your paper, you might go ahead and say, okay, I know that R of t is in for F of 1 or Y1 if you're using the 84 plus, or F of 2 and Y of 2. So just writing that on your paper is helpful, so that way you have a visual reminder of which function is which, so when you go to type it in your calculator, you know what to use. Okay, so we decided that for our first one, we were just looking at that integral from 0 to 6 of R of t dt. So let's look at the Inspire first. So I already have F1 and F2 here, and so I know that my R of t function is going to be my F1. So let me go ahead and go over here. Okay, so now when I want to type this in, the goal of this is since I have this saved as F1 in my calculator, I should not have to retype 2 plus 5 sine of 4 pi t over 25. Okay, I've already typed that in once, and so let's utilize what I have written in there. So I'm going to go ahead, pull up the integral. I'm going from 0 to 6. One thing you might just want to double check is making sure that your calculator is in radian mode since this is a sinusoid. Okay, so I have this saved as f of 1, and so what I'm going to do is I'm going to recall that, and I can do that with the variable or the var button. Okay, when I type that in, or when I press that, it pulls up both f1 and f2. So I know that I want to use f1 since I'm using R of t, so I'm going to select that. Parentheses are going to open up, and so I'm going to type an x in because that is my variable. Then I'm going to write dx, and I'm going to press enter. Okay, so I know that this is going to be equal to 31.851 cubic yards, and we'll write that down in a second. Okay, if you are doing this with the TI 84, okay, same thing. Let's go ahead and bring up our integral. Okay, we're going from 0 to 6. Now, here's the cool thing. Okay, I can still do the same thing. I can pull up what that F1 function is. How I'm going to do that is I'm going to press the alpha button, and then I'm going to press trace. And what that's going to do is that's going to bring up a list of all of my possible functions that I've defined over here in y equals. So I want y1. Now, what you need to remember to do is I want to use this as function notation. So I'm going to go ahead and put an x inside of the parentheses. And so now that's going to read like f1 of x. y1 of x, okay, but they're gonna read as the same thing. I'll press enter, I get that 31.815, or I guess 816. All right, okay, so there we had it for the first one. So part B says we're gonna write an expression for y of t, the total number of cubic yards of sand on the beach at time t. So what that means is that we're gonna write an accumulation function. I wanna take into account the fact that we're adding sand in, but we're also subtracting sand out, okay? And I also have to know that I have sand to begin with. I'm not starting from 0 sand. So for y of t, I know that y of t is gonna be equal to my initial condition of 2,500. Okay, then I'm gonna go ahead and let's go ahead and add in our accumulation function. So I'm gonna go from 0 to t of s of t dt. Okay, and then I'm gonna subtract out the amount of function, or the amount of sand over some sort of time period t of r of t dt. Now, I wrote this down. There's a couple of things that we're gonna go ahead, I wanna point out and we need to modify. So first of all, I know that I'm going from 0 to t because my time period, or my like domain of t, is either from 0 to 6. And so what this is representing is that when I plug in some sort of t here, it should be within that domain. And then I'm going to plug in that value here, and that's going to calculate how much sand I have at that time t. Now, because t is the variable of my function, I also see that I have t's as my, within my integrand and within my... it's my variable of integration, and I know that those should not match because really this is a function. So what I'm going to do is I'm going to go ahead and I'm going to utilize a dummy variable. It doesn't matter what you could use. I'm going to use x just to keep it simple. But I should change that. Okay, the other thing that I noticed, and this is kind of extra, you don't necessarily have to do this. I see that my bounds are the same on both of those integrals. What I can do is I can condense those into one integral altogether. So I'm going to rewrite y of t is equal to 2,500 plus the integral from 0 to t of s of x minus r of x dx. Now that you can only do that, remember, when your bounds are the same. They are, so I can do it. Don't always assume that AP is going to make you have the same bounds because I've seen it where they are not. Okay, so for part C, I'm going to go ahead and flip over to my page. We're going to find the rate at which the total amount of sand on the beach is changing at time t equals 4. So one thing I'm going to do, I think that I'm going to have to utilize that function y of t that we just used, or we just wrote, so I'm just going to rewrite that. Okay, so first, a couple of keywords that stand out to me, and I don't ever think it's a bad idea to like mark up your page or your whatever you're writing with some keywords. Okay, we're finding a rate at which the total amount of sand on the beach is changing at time t equals 4. So remember, y of t represents the total amount of sand that's on the beach at any given time. And so we want to find the rate at which that's changing. And so what we want to do is I want to find y prime of t. Okay, that's the rate of that total amount of sand. So I need to derive my function that we just wrote. So the derivative of 2,500 is 0. Okay, and now we need to derive the integrally defined function. So the derivative of the integral from 0 to t of s of x minus r of x is just going to be s of t minus r of t. Okay, which means a simpler way to write y prime of t is going to be s of t minus r of t. So it's just the differences within those rates. So we're trying to find the rate at how the sand is changing at time t equals 4. And so what that means is that I want to find what y prime of 4 is. And so that would be looking at s. Ooh, careful. Okay, so s of 4 minus r of 4. Now notice, I was really tempted to try to put that prime there, like s prime of 4, but remember that s and r are already rates, okay? So they already are derivatives, and so I don't need to derive them again. So now we're going to go ahead and go to our calculator, and let's talk about how we're going to type all of those. All right, let's start with the inspire first. So in my calculator, I want to go ahead, I'm going to type in f of 2 of 4, or f2 of 4 and f1 of 4. So again, I'm just going to use that variable button, and then I can toggle back and forth between the two of them. Now, one thing that's really important here that, and it's why we already did this, but when I go to type this in, remember s is representing the second one that we typed in, and r is representing the first one. So that's why having these written out on your paper is helpful, so that way you don't forget which one's which. Because if I were looking at this, I might think, okay, I'm going to use f1 and f2, and that's not the order in which we stored them. So here's the deal. I'm going to go ahead and I'm going to type f2. It already has that parentheses for me, so I'm just going to type in 4, like function notation, and then I'm going to subtract f1 of 4, and we get our rate, and we'll write that down in just a moment. Okay, next up is the TI-84. Okay, TI-84, we're going to do the same thing that we just did beforehand. I'm going to press alpha and then trace, and then I'm going to do the same thing. Okay, I'm going to f of 2. I'm going to put parentheses around it, so then I can type in the 4 like function notation. Okay, and then I'm going to subtract y1. I don't know if I keep saying f1. I'm so sorry. It's y in this case. Okay, and I'm pressing enter. Look, I get the same thing. So let's go ahead and write that on our paper. Okay, so we saw that we got negative 1.909 cubic yards per hour. Okay, and so how I'd want to interpret that, if it was asking me to interpret it, is that it looks like the total amount of sand at time t equals 4 is decreasing. Okay, so we're kind of in that lower mode. Okay, so for the last part, for times 0 to 6, at what time t is the amount of sand a minimum, and what is the minimum value? Justify your answers. Okay, so the first thing that sticks out to me here is that we are needing to find a minimum and then what the minimum value is. I also see that we are on a closed interval, and so what sticks out to me is that we are going to be using the candidates test to help us do that. Okay, so I know that for the candidates test, I want to take a look at where. So it's asking about the amount of sand. So again, that's going to go back to y of t. Okay, it's asking for where y prime of t is equal to 0. Because I know that for the candidates test, I need to look at both my endpoints. Okay, that's going to be 0 and 6. I already have those, but I need to find my critical values. So looking at that, I know that that's going to be where s of t minus r of t is equal to 0. Okay, or another way that I could manipulate this is I could say that this is where s of t is equal to r of t. And so what this does is this actually presents us with two different ways that we could use our calculator to help us find what this value is. Okay, and I know that I want to use my calculator for this because what I would be doing is I'm going to set a rational function equal to a sinusoid. I can't think of a lot of algebraic ways that I'm going to utilize to get t by itself and solve for t, and so that's where our calculator is going to come into play. Now, depending on which way you want to do this, let's chat about each one. So the first one, how it presents to us, is it says that we are going to actually define a new function. I might call this y3 or f3. Okay, I can define a new function, and I'm looking to see where it has zeros. Okay, so s of t and r of t can be combined together into one function, and you can find the zeros of them. Okay, the other representation, and this might be the the more friendly way, it's going to save us a little bit of time, it's asking where the two functions are equal to each other, and this is where we're looking for the point of intersection. So just note, either way is totally fine. You can utilize whichever one you want. I think that the point of intersection one is going to be a little bit easier because I already have them graphed. It's going to take a little bit more time to define a third function and then find its zeros. So let's go ahead. We're going to go over to our calculator so we can find out where those zeros are. Okay, so let's go ahead and we'll start with the inspire. So I'm looking to see, I'm going to choose the point of intersection method, okay? So I'm going to go back over to my graph, okay? And I know that we're doing this from 0 to 6. And so one thing that I noticed, it looks like I'm getting a little bit close here. I could check to see if there's a point of intersection, but I do know for sure there's one there. So let's go ahead and start analyzing our graph. We're going to find that point of intersection. Okay, and I'm going to look for the one. Oh, where'd you go? I've never seen it do this. Okay, let's see what happens. Okay, I don't know why it is blinking at me, but I did find my point of intersection. So here it is. Okay, so it's at 5.1179. Now, just as a reminder, depending on how you are floating your values, you might not see all of them. You can hover over it with your cursor, and then if you press the plus, you can get more decimals. And I see that this isn't something that I necessarily want to round, okay? So we have a couple of options. Either write down like 8 decimal points on your paper, and you're gonna know that you're gonna have to go back into your calculator and write out all 8 of those points. The other method that we can do is we can actually save what that x value of the point of intersection is in our calculator, and so when we go to utilize it in our in the next steps of our problem, we can just pull up what that stored variable was. So how I'm gonna do this, I have to be very careful about it, okay, is I'm going to hover over it like I am, and I'm gonna press Control Store. Nope, okay, hold on. I'm gonna click on it first, and now I'm gonna press Control Store. Okay, it's gonna open up with the VAR, and so what I'm gonna do is I'm gonna choose one of my variables down here. You can't see that. One of my variables down here to store it as. I would just say don't do X, okay, because that's usually something that we use like for a function, and so that probably isn't a good one. So let's just choose A. Okay, so I'm gonna let A equal this. I'm gonna press enter. And so now I can tell that that value has been stored because look, it's really dark, okay, it's bolded. And so what that means is that when I go in and go back over here, because I know I'm gonna have to type in something with an integral because this is the candidates test. If I press A, it's going to utilize that value in all of its decimal glory. Okay, so it's stored all of that in for you, and so that's already there for you. Okay, we can do the same thing now with the TI-84. Okay, so TI-84, I'm looking at that graph. Okay, I'm gonna find that point of intersection. I'm going to do this by pressing second trace. Okay, that's gonna get me to the calc menu because we're gonna calculate something. Okay, I'm gonna intersect. And so what you wanna do on the 84 is I'm going to trace along my curves until I'm close by that point of intersection. Okay, so here's one. If I press enter, it jumps me down to the other function. So here I am, I'm gonna press enter again. It gives you a fun little guess. You're gonna press enter a third time, and it tells you that point of intersection, okay, the 5.11786. Now, the cool thing about the TI-84 is it actually already has that value pre-stored for you. So if we go back over here to just the main menu, if I press the X variable, look what it did. Okay, it remembered that that X function, that X variable that we just calculated was that. So you don't have to store it as anything separate. Now, if you want to, that's totally okay. We're gonna do that by pressing, answer. I'm gonna press the store button. And then if I wanted to call that alpha A, I could do that as well. And so now every time I press alpha A, it's gonna remember that value. So now that we know where that point of intersection is, and that's the only place where the two functions are going to intersect on 0 to 6. Let's go back over and let's kind of utilize that for our candidates test. Okay, so we just found this value as our point of intersection. That's the only one on there, and so let's go ahead and set up our candidates test table. Okay, so I'm going to have t and y of t, and then there's 3 values that I'm testing, okay? First of all, the endpoint 0. Then the next one is A, and what I can do in my table, since I've already defined what A is over here, I can just use A here, unless you want to rewrite all of those decimals, totally up to you, but I am all about less work. And then 6, because that's our other endpoint. So now to calculate y of t, I know that I need to plug basically in for my function y of t. I'm going to take those values and I'm going to plug that in for t. So what that means is that this first one, I'm going to have 2500 plus the integral from 0 to 0 of s of x minus r of x dx. Okay, and I see that my bounds are both 0, and so that tells me that my amount of sand is 2500. Duh, we were told that to begin with. But I'm glad that we figured it out, and we've really clarified that in our brains. Okay, so the next thing now we're gonna do is I'm gonna take my, my critical value A, and I'm gonna plug that in for my bound, because that's what I wanna test it at. So I'm gonna have 2500 plus the integral from 0 to A of s of x minus r of x dx. So I'm not going to jump back to my calculator because I believe in you, I really do, but when you go to type this into your calculator, again, because you've already stored that variable as A, or if you're on that 84 and you just chose to leave it as X, Okay, you can go ahead and do that, and it should calculate out what all of this is. And so when we do that, I believe that we get 2,492.369. Okay, now I'm going to do the same thing last time for 6. I'm going to have 2,500 plus the integral from 0 to 6 of s of x minus r of x dx. Okay, when you go ahead and type that into your calculator, you're going to get 2,493.277. And so our goal for this was to find the minimum amount of sand. And so for the candidates test, you're just looking at which one gave you the least output value. And it looks like that was, in fact, our critical value. Okay, and so remember that for the candidates test, when it says to justify your answers, really your work was that justification. So how I'm going to write this out is I'm going to say, I'm almost out of room, so hopefully you wrote smaller than I did. I'm going to say the amount of sand is a minimum when t is equal to 5.11, let's go ahead and round that to 3 decimal places. Okay, so 118 hours, and the minimum value is 2,492.369 cubic yards. Now you could also write that as there's a minimum amount of sand, or the minimum value or the minimum amount of sand is the 2,492 when t is equal to 5.118 hours. So you can utilize that structure that we've kind of utilized in some of our past units. Okay, great job, guys. You did amazing. Next class period, we will also continue to work on this. Again, we want to get you good at utilizing our calculator. Use it for what it's worth. It's gonna be a helpful tool. So remember that it's a helpful tool for you. Okay, that's all I have for this video, so I will see you.